Come back to the breadboard. This is the third video in a unknown number to do with building a Voron 2.4 R2 350 by 350 millimeter bed 3D printer. In the first two videos we looked at dealing with what is a Voron, going through the customization application, bill of materials. Some things I may have to fudge a little bit, as we'll see as we go through the series, to get the printer built. In this video we're going to be looking at building the frame. So without further ado, let's switch to the bench and have a look at some of the components we're going to need, some of the tools we're going to need to get that done. What we have is up at the top here, we have an MGN 12 rail, linear rail. We have an MGN 9 linear rail. The MGN 12s, these ones here, that's used for the x-axis only. Everywhere else on the z and the y-axis uses MGN 9s. Now that's great, and the reason they picked MGN 9s is when you put them on a 2020 extrusion with the carriage, it does not exceed the thickness of the extrusion, which means that you can put covers onto the outside of the printer and the rails will not rub against them. If you use MGN 12s, it would. All of the Voron 3D printed parts are designed around using MGN 9s. Now I've discovered that my vertical rails are actually V rails, and if I show you an example here what a V rail looks like, you can see here that there are slopes. There's 45. If you go down on that one and back up on this one, it's a 90-degree slope, and the width at the top of this slope is actually 9.2 millimeters, slightly wider than what the MGN 9 rail is. Now this is an 80 by 40 C section of extrusion. I've used these in the past for my CNC machine. Can't use the MGN 9s easily on the V sections. Now some people have used 3D printed inserts to sit under there, which takes up the V shape, and I might try that. I'm not completely against getting some proper extrusions. So the first thing you've got to do is decide what size frame you're going to work with, and that's where you go through the configurator. I showed you the configurator in the previous video. One of the things that comes out of it is telling you the length of each of your sections that you need. Now I've already cut all the pieces already from the scraps that I had, and but I wanted to go through some of the important aspects of what you've got to do when you cut these, and also what can be different about different extrusions. None of the ones I have here are Misumi extrusions. There you go, I remember the name. They're close, but they're all 20 by 20 T-slot extrusions, but the Misumi ones have a slightly different profile about them. Now if we go back to these other extrusions, here's the V wheel one, and you can see here the gap between them is 6.25. That's no big deal because the T-nuts that go in will go well into the slot and they'll still clamp up well. But the gap across the top, sorry, I said 9.2 before, I meant 9.16. Your linear rail is 9 millimeters wide, so it's going to be sitting just a fraction into there, and it's going to make it very difficult to stop it from twisting into aligning with one of those slopes. So by 3D printing something that potentially could insert in there, in my case, I might be able to avoid that, and it's worth giving it a shot because I already got them. Anyway, so that's a V slot that's used for a lot of the Chinese import 3D printers. It's used a lot in some of the lower cost CNC machines too. In fact, the two that I built years ago both use V wheels. The extrusions are much bigger, but they're still based on the 2020 format. So like I showed you before with that 8040 C section, my big 1.5 meter by 1.5 meter CNC actually uses that C section for its axis. So yeah, this is why it's the worst kind of extrusion you can use is this V wheel kind. Now, one of the other ones that is very common, that if you get standard extrusions, is this one. And if you look at this one, you'll see that it's almost perfect, almost, but the gap in between the two is 6.2 millimeters. As I mentioned before, the gap is actually okay at 6.2, but there's a little half millimeter by half millimeter notch. Not sure why it's there, but it is on each side of the slots. So that means it's 7.2. So your 9 millimeter rail will go in there, but it'll only have a 1 millimeter on either side. So that's, as long as you align it properly, that will be perfectly adequate and clamped down. The other thing you have to notice is that the internal hole diameter is actually 5 millimeters instead of 4.2. So you can't use that for an M5 screw. You'll have to go up to an M6 screw. And that's perfectly fine too. That's a very, very trivial variation in this situation. Now, I have a lot of this extrusion. In fact, all of the horizontal frames on my build is going to be made out of these. And I'm going to be, and the flying gantry is also going to be made out of these. So I'll make slight adjustments for the holes by tapping them bigger. When it comes to the flying gantry, it really doesn't make any difference. This is the frame that we're trying to build. So this is the initial frame. Now, I've kind of got a little bit ahead here in that this is already built, and I've taken some stills and video, so I'm going to be showing you as we go. But this is what we're aiming for. You can see my vertical pieces here. These are V slots. They're 700 millimeters long. And all these pieces are the extrusions that I have, which have the little notches in them. But they'll work perfectly fine. These top ones, you don't actually put any linear rails on them at all, nor the bottom ones. You only put T-slots in and attach them. So it really makes no difference there. The only real difference that would be made is on the flying gantry, where you will have the linear rails for the X and Y fastened. On this, you're going to have linear rails fastened on the inside edges of these vertical black rails. So taking a look at what we have to achieve when we're building this, there's going to be some cutting and some drilling. So what we have to do for our joints is here. I've taken a close-up picture so you can see where I've drilled through the side 10 millimeters down right through on the inner section, and same on the other direction, because when we join these pieces of extrusion together, we're going to put a cap head screw in there, a button head screw, sorry, and we're going to reach through these holes with an Allen key to tighten it down. So it's going to be gripping on the outside edge of the T-slots and pull that extrusion in really, really tight. And it makes for a very, very tight joint. The extrusions that I have to tap are yet again slightly different. So you can see it's the 20 across 6.2 millimeter gap. It's got those little half millimeter by half millimeter notches in it. But what's different on this one is it has this weird shape extruded down the middle. I am not sure why it's there in that shape, but the basic circle is still here, and you can still tap it M6 tap so that you can screw it in, and it still gives you a very, very tight fit. By the time the tap's done, it's eaten quite a way into these little notches that are around it as well. So not a big deal, it's just yet a different profile. When you look at these to join them, right, these are the ones I just showed you with the little bit of a weird inside hole. They still work perfectly well. You can see this is an example where I didn't quite join them together properly. I need to slacken that Allen screw off and drop it down a little bit. Now there's some critical aspects of this frame that you need to know about. So let me just pick up a picture here. There's going to be linear rail running down this edge and this edge. These two extrusions have to be perfectly parallel to each other, because as the gantry moves up and down, because remember with the Voron 2, the bed stays fixed at the bottom, and the head is the piece that moves up and down inside the printer frame. So these two right hand side vertical frame pieces have to be perfectly parallel to each other. These left two have to be perfectly parallel to each other, and then the left two to the right two have to also be perfectly parallel to each other, because the flying gantry is going to be suspended in between them, and the last thing you want is to be twisting that gantry or making it distort in some way as it moves up and down. So lots of perfect alignment is needed. The other part is that on the top, the cutting of these is not hugely critical, but they should be as accurately as cut as possible. I mean, mine are exactly 700 millimeters, that's how they came, but if you had some that were meant to be, I think 530 is what you use for or 550 for a 350 by 350 by 330 frame. But if the length of this is only 695, that's not going to be a big issue, because there is a bit of leniency in the length, and it's not going to affect anything terribly. But these ones here, they need to be pretty close to what is called for in the bill of materials. But if they're a millimeter off, it's really not going to make any difference. But what is important and critical is that this one and this one and this one and this one, so the ones that run from left to right on the top of the frame and the bottom, have to be identical length. The length could vary a little bit from what you desire, but the important bit is they all have to be identical. So one thought is to set up a jig and cut them all together. There are plenty of videos on YouTube about cutting the frame pieces. Now also, these left and right running front to back frame pieces, and the top two running front to back, have to also be identical in length. The frame, strictly speaking, for the 350 by 350 is an actual perfect square. But if it isn't perfect square, as long as these are parallel and identical lengths, and these are parallel and identical lengths, top and bottom, left and right, then your frame is going to end up being completely square. Now I will, a little bit in the video, show you how to measure whether you are a true square. Right? You can use a machinist square like this, and when you have, I've just got some pieces here, when you have them screwed together, right, you could use the machinist square to check that they are perfectly square or not. Right, now this one, I'm just holding it together tightly, but I can see that it is actually very, very square, even there. These were cut on my compound miter saw outside, and they seem to be fitting together very nicely. But when you're putting this together, if you've got slightly different lengths anywhere, one might pull a piece out of alignment slightly when you're screwing it together. So you need to be aware of that. So measure with at least a machinist square, or I have a slightly cheaper version which you would typically use for woodwork and framing, you know, carpentry and things. This would also do. Just make sure it is truly square. Otherwise you'll be chasing your tail trying to line things up. But another way of doing it is, once the frame is actually assembled, and I'll do a demonstration later in the video, if you take your frame and you run tape measure from corner to corner, and pay attention to the point on the tape measure that you're measuring and where you're hooking onto. Take a measurement. Let's just assume that it's 50 inches. So I'm just randomly picking a side. This should also read the exact same length. If it isn't, and assuming that your extrusions are the exact same length, so in this case these are 700 millimeters, then if the distance is different, it means that the frame is skewed slightly, and you need to correct that, because if you don't, then your head is going to be slowly drifting off in the direction of the skew as it raises up from the bed, and that's going to give you a potentially crooked print. Now if it's only a fraction of a millimeter out, it's probably not going to make a huge difference. Okay, so here on the bench we have it's just an offcut of an extrusion. It's the same as I'm using for all of my horizontal pieces in my frame. As you can see, it's got a bit of one of those square holes in the end, and that's what I'm using for my horizontal pieces of the frame. So what we need for this, because this is a basically 5mm hole, albeit it's got a few bits of square holes in it. See, it's basically a circle with little square bits tabbed out of the, I say corners, but it's a circle, so there are no real corners. But you get my drift. You can see from that picture what exactly we're going to be tapping into. So let's put this back in the vise and we will tap it. So this is the tap we're going to use. This is what they look like. This is a tap holder and this is the tap. This is very hard, so you need to be careful. If you do use a power drill to do your tapping, you need to go carefully. Now, one of the things that is recommended when you do this is a little bit of lubricant. Now, I happen to have some cutting fluid, which I will use, but if you don't have any of this, because you're going by hand mostly and you're not doing a lot of it, a little bit of WD-40 would also do the trick. So all you need to do is just put a little bit of it on the tap. That's probably more than enough. And you can see that a little bit lubricated on one side, but once we start tapping, that's going to get in the hole and spread around. Now the trick with the tapping is, hopefully it'll focus again, is you need this to be a straight line straight down the tap. So your tap needs to be aligned down the center if you want it to go square. Now it will fairly well self-align as you go, and then once you have this in place, you just need to start rotating. It will start to bite and you don't need to push too hard. So I'm going to line this up both inline horizontal in both planes so that it's going in square, and then you just start rotating. It will start to grip it itself as you're going in. You may not feel it initially, but it will start to bite down. And usually the trick when you're tapping any metal is you go in a few turns and then you come back out a little bit, just a quarter of a turn. Then you wind back in again, go in a few turns and back it out. And the idea of this is to get the swarf that's being cut inside here loose, and there's, as you can see, there are grooves in here where it can collect. So I'll quickly just wind through this 90-degree end, so you can just spin down on this. Now we'll show you another shot. I'll do the other another piece, and I'll use an electric drill. In this case, because there is a lot of clearance, you can do it. So let's just get that. That's as far as the tap will go. I've run out of threads here. So, and that's more than enough anyway that we need. You can see it very easily comes back out again. It's actually made the threads quite nice. And if I take an M6 bolt, you see it'll now thread in very nicely, and it's not too wobbly and it gets a good grip. Okay, now that's doing it with a hand tap. The same principle applies if you're using M4s, M5s, M6s, M3s. Let's quickly put another piece of extrusion in here, and I'll do this with an electric drill and show you the difference. Now I wouldn't recommend necessarily going straight. I'm going to use this rigid. This is pretty typical of what you can pick up at the hardware store. I wouldn't recommend necessarily going in before you've done any practice by doing it by hand. And I would practice on a scrap piece of aluminum first, because if you make a mistake, you could, one, snap your tap in the end of it, and if you have to then cut it off out, you may not have enough length on your aluminum left. So what you want to do with your drill is take the torque down, right down. So I can hold that. Yes, sorry about the noise. Because you don't want to risk snapping the tap, and it will snap if you're not careful. Let me just wipe off the tap with the existing swarf. A little brush or something will do that nicely. Just want to get most of it off. So we'll just put a little bit of cutting fluid back on here. Just a drop is enough. Now this time it's going to be noisy, but same thing applies. Line everything up. Now you can go in, back it off a little bit. Just let the tap pull you in. Don't push it because you might destroy the threads. So if you're doing a lot of thing, it's going to be much easier to use a drill like this. And that's really all there is to it. That's 2 pieces done, and we're basically done. So the one thing you might need to do after you're done, if you look at this, I'll show you on this one, you can see there's a little bit of thread that's been come up in the hole here that's sticking proud. So you need to file that smooth, or get a very large drill and just countersink it slightly so that that's not protruding, because that will interfere or potentially interfere with joining your sections together. One thing to note, I just noticed on this piece of extrusion, when you're cutting your extrusions to length, you will sometimes get a little, it just broke off, oh, don't know where it went, on the floor somewhere. You will get burrs on the edge, so you also need to file those off to make sure there's nothing sticking proud. You want a nice flat and parallel surface so that when you check it with a square, right, it's a nice 90 degrees. Alright, so that's that bit done. Let's try doing a little bit of assembly. So when you're drilling these extrusions on the ends, you need to put a hole right through in both directions. This is for the vertical ones, and the idea is that you can get your Allen key. It needs to have plenty of clearance for your Allen key to go through, right? Because the screw you're going to try and put in to assemble this is going to be something like this. This is an M6 screw in my case. It's going to go into the T slot like this, and it's going to attach basically like that. And you want to be able to get through at the 10 millimeters in point, so that when this is all assembled, it is nice and flush on the top, and of course at 90 degrees. And because you're going on the T-slot part of it to put your screw in, you can get both sides done and you have access in both directions. Here's a quick video of me doing the drilling. I did make a sort of a jig on my drill stand. So what I'm showing you here on the screen is a jig kind of that I set up in my workshop outside. It's sub-zero right now, so I really don't want to go out there and do some live videoing. But you can see here I've got my drill press, and I've used a couple of pieces of scrap aluminum to set up like a sort of fence and an end stop. And what I'll do is take a piece of the extrusion that I want to drill and just set it against this piece here and butt it up against the end of this one. Make sure that's square. And what I did to line this up was I put a piece of extrusion in here and then tweaked the position of these so that the drill is 10 millimeters from the end of the extrusion when I've got this butted up tight against here, and also when I bring the drill down, it is right in the center of the extrusion slot. Now if you feel a little less comfortable going full size right away, you can always drill it with a pilot hole first and then follow it on with a bigger drill. Obviously if you don't have a drill press or something to set up a little bit of a clamp, you can always just measure it, spot it, put a center punch mark in it and drill it by hand. Just make sure that you're going parallel straight through. Not that it's a huge deal in this case if you don't get it parallel, but you want to be able to get that Allen key in and have a little bit of wiggle room so that you can tighten it down. Anyway, that's what I used to do the a jig for drilling all of the ends, and you have 8 of them at minimum to do if you're having to do your drilling yourself for those vertical frames, so that you can have the holes to screw everything together. That's lining up the extrusion I want to drill. I'm just using a test piece here to show you. I'm making sure it's pushed in tight against the end stop and against the back frame. Just drilling down through. We got through the first section, Now you've got the second section. Now you need to just turn it around, blow away the shavings so that you're still being able to butt up against the end stop and the backrest. Drill through again, and basically you're done. You can get some 3D printed little jigs that would help you as well. They won't last very long because they're just plastic, but they're good enough to be able to get your holes drilled reasonably accurate at the end of your extrusions. Okay, let's look at assembling one of our corners. This is what we're trying to build, this Voron here. We're using very similar colors, and we're using the bigger size of 350 by 350 with an extended vertical of 700 instead of about 530 for the rails, for the extrusion sizes. Vertical Z-axis is declared as 500 in my case. So if you go down here through the manual, it's very detailed. First thing you'll come is across a hardware reference which describes all the different types of things you're going to need. Here's a bit about what we're going to do. So we're screwing the button head screw into the end of the extrusion, sliding it down into the top of the frame, and then you're reaching through the extrusion and tightening up that screw, being careful, as you can see here, that you get everything all nice and perfectly aligned. Okay, so the first thing we're going to build is this. So going down here, this is a list of all the different extrusions. Now the length of these extrusions will vary between the different sizes of the printer you're building. So what you've got to do is go through the configurator. It'll then tell you what they are. Now unfortunately, when the configurator puts out its bill of materials, like if I bring it up here, this is a bill of materials, and if I go to the frame somewhere here, it really doesn't tell us what the lengths are. It just tells us we need 18 pieces for the 350 build or the 250 or the 300, and it's from Misumi. Now if you want to know what the lengths are, you can go in and look in the configurator here. So it tells us the lengths and how many we want of each. What it doesn't tell you is whether it's an A, B, C, D, or E component. If you go back to the manual, you can see that each of these are listed as A, B, C, D, and E, but the bill of materials doesn't tell you which one's which, so you have to figure that out. Now it's fairly easy to do so because they all do have a specific order in size. You can see if you line these all up longest to shortest, you would have B's first, then A's, then C's, then D's, then your E. So it's pretty easy to figure it out once you've got them. What we're doing is we're going to be using a lot of A's, 8 of them. These are the horizontal pieces, and 4 of the B's. We will use the last 2 A's as well. Actually, if I go back to here, you've got 1, 2, 3, 4 A's, and you've got 1, 2, 3, 4 A's here. These are the 4 B's that are in there. They're the only ones of that length. And then these 2 are also A's, and they use little angle brackets on the end to connect to the frame. Now I don't have any of these angle brackets, so I'm not sure what I'm going to do yet. I may just 3D print something for now, or use something a little different that I already do have. May take a bit of tweaking. Anyway, that's what we're going to be building, and that's where all these extrusions come from. Alright, so here are the pieces that I have. Okay, I've got a long piece of, these are just scrap pieces for the sake of showing you, of extrusion that I've drilled through the ends of it, right, 10 millimeters down and right in the middle. And as I said, if you look at these extrusions, focus, you can see there's like a line down the middle. That's actually a notch, so it will guide your drill to be right in the center of the extrusion. If you drive bigger than the Allen key size, so you need an M5 Allen key for an M6 screw typically, then if you drill your hole at least 6 millimeters, then your Allen key should fit through no problems at all, right, with a little bit of play. So what you want to do is, in your horizontal pieces, you want to just screw into it. Now you want to put it almost all the way in. You can see there's a lot of thread to get a good grip in here. So screw it quite a way down. You want it to be able to fit in there and not have a big gap. So we'll screw it down a bit more, just minimizing what you need to do to screw it together. That's a chewed up end, so I'm going to assemble. Actually, that's the end I haven't drilled either. So here's the end I've drilled. So we'll put that in. You can see it's still a bit loose, but if we take our Allen key, we can go right through. All right, and we can snug that up. Now what you want to do is probably have it on a very flat surface. So now you can see I've got that for pushing against, nice straight surface. Push these two pieces together while holding that nice and smooth. Get your Allen key in here and snug it up. Now, so just hip that up reasonably tight and then you can bring it away. See, I still managed to get that a little bit wrong on here. Just a little bit proud on this. So what I'll do is I'll slacken that off and try and smooth it up again. Keep it all together. Like that, and now, right, we're much better now. That's nice and smooth now, right? And it's aligned this way. So we'll just nip that up. Now, when you nip these up, just be careful you don't get this to twist. That's the last thing you want, right? So when you tighten this up, you don't want this to twist. See, I can feel that start to twist this as I tighten it. And that's what you don't want to happen. So I probably messed that up a little bit now. All right, so we'll keep it flat on the table. Sorry, get it around here. Just press down. As I said, a clamp would probably help, and just tighten that up. Now that's not going to go anywhere. Okay, now when you do the next one, it's the exact same process. Once you've got all this assembled, you could probably go back around and nip them up a little bit. If you've got blue thread locker, that will definitely help to keep it nice and tight once the thread locker sets. There we go. And then you do the next one in the exact same way. So we'll put an M6 in the end of here, in my case. Now you're going to go in the opposite, different direction. Okay, you're going to be going this way or this way, depending on what corner you're on. So let's put that down here. So I'm just going to loosely tighten it down first. All right, that's just snugged enough that I can still move it and position it. And we're just going to get this all tucked in here. All right, keep everything pushed down nice and square. And then you can get back in the end here and do the exact same thing. Tighten it up. And take out your Allen key, hopefully. There we go. So now we've got both corners done. Now, if you've cut everything right, and if the gods are smiling at you, then what you should have is nice square angles here. And that one isn't. See the gap at the end there, and that's just a short bit. So that would be unacceptable. And this one is, actually that one is very good, that direction. See there, that's nice and parallel. So what you might be able to do with some of these, there is some latitude. These pieces are not going to carry any linear rails or anything, they're just structural for the main part of the frame. But you do want them to be straight and parallel. Now when you join it to the other end, it will make a little bit of adjustment just because they're all the same length, so they'll try and force themselves to fit. But what you can do is try and, all right, I managed to get it loose. So what I was going to suggest is just try rotating it 90 degrees and tighten it up again. Let's get it all lined up. you've got an offcut of an old kitchen counter or something like that, a granite one or something that's extremely flat, that would be a good aid for assembling this. Obviously you need to make do with what you've got, but okay, so we're nice and tight. Now let's see if we've got it square. That's actually pretty good this time. And we'll just double check that one, which is still nice and square. Now obviously if you're getting factory cut extrusions, you're not going to have this issue particularly. Yeah, that looks pretty good this time. Yep. That's basically putting your corners together. The more accurate you get your extrusion cut on the ends, the better it'll go together without any hassle. Okay, now when you look at the build guide, just go back to that. Right, this is pretty much what it takes you through. So put your end screws, in. Screw one corner together, then repeat for the other corners, so you end up with all your verticals, and then you're going to screw the tops on. And once you've done that, these two pieces I'm not going to worry about right now. These are just to hold, as I said, hold the build plate. Then once you've done all that, you're going to make sure that all of your angles, once you've got your frame here, you're going to make sure all of these angles are correct. Okay, so let me pull up my frame. Might be difficult to get it on the bench. And we'll do some measuring in a way that we can verify whether it is square or not. Okay, we've checked it with the tool square, but there's a way you can do it with measuring as well, which is a bit more accurate over longer distances.